Hello, and welcome to Vector's Virtual Software Testing Symposium. My name is Krueger. I'm a Senior Field Application Engineer, and this September I'll celebrate 17 years with Vector. Thank you for joining this presentation titled ISO 26262 ASPICE Audits Key Testing Capabilities. In the next 20 minutes, I'll briefly introduce both the ISO 26262 and ASPICE standards and review how the two standards overlap. Then I'll share 5 key areas that you may want to consider for your audit, and for each key area you'll see how Vector's software testing solutions can help. On this slide I'm showing over 30 years of software development process evolution. On the left you can see the family history of the ISO 26262 standard, and on the right you can see the family history of the Automotive SPICE standard. The Automotive SPICE standard has got a little bit longer history, so it evolved out of some activity at SEI in 1988 that led to some work at Carnegie Mellon with the capability and maturity model in 1998. And then you can see it followed on to the ISO 12207, and then for the Automotive SPICE release in 2010, that was version 2.5. And then the current release is version 3.1, which was released in 2017. On the left, you can see some of the evolution of various safety standards in like the medical, space, and aeronautics industries. You can see the DO 178 B and C standard that goes back around 1992. And then later in 1998, the 65508 functional safety standard, which is a parent standard to all of the functional safety standards underneath. And then down there at the bottom, you can see in 2011, the first automotive functional safety standard 26262 was released, and then the current version was released in December of 2018. Here you can see the two standards. The ISO standard, interestingly enough, is actually made up of 12 parts or 12 different documents, whereas the Automotive SPICE is a single document. One of the nice things about the Automotive SPICE standard is if you go to their website or click on the link on the previous page, it'll take you right to the download page. So you can freely download the Automotive SPICE standard. The ISO standard, like all ISO standards, you have to purchase. Both standards are large and challenging. These figures are taken right from the standard documents. And right away you can start to see a little bit of similarity. For our presentation today, we're going to concentrate on some of the middle areas, but you can see that both standards have supporting processes around the outside. Processes like management, supply chain, and various other items. The 26262 standard, like I mentioned, is 12 parts or 12 different documents, and it's over 800 pages, where the Automotive SPICE is just a single document and it's about 130 pages. So if we remove some of those outside areas and start looking in the middle, we can see that both standard has an area for system processes and software development and testing processes. So on the ISO 26262 side, we're in part 4 for the system level activities and part 6 for the software activities. And on the SPICE side, you can see that the system activities are in a section SYS, SYS, and the software engineering is under a section SWE. If we refine those middle areas a little bit more, we have these two new figures that are also from the documentation, and I added the red dotted line so we can see that above the dotted line we're in system activities and below we're down in software activities. But right away you can notice that these both look like kind of a traditional V model development, and we can see that certainly the software part has the same 6 kind of activities. And some of the basic ideas here is you start with your project or your system requirements. You're going to go through a process of breaking those down into architectural designs and then software designs. You're going to be doing some requirements analysis, and then you get to the bottom on the left where you're doing some component design or software detail design. Once you start moving up the right side, then we're into verification and testing activities. So let's take a look at that. So if we are just looking at the right, we can see that. And then if we take just that right side and compare the two a little bit closer, we can see that there's about 4 typical processes that your auditor is going to be looking for. He's going to be looking for some kind of software unit test or unit verification activity. In this case, both standards use the exact same nomenclature. And then on top of that, we have some software integration activities or a software integration test process. On top of that, the 26262 calls it testing of the embedded software, whereas the automotive SPICE calls it software qualification test, but you're still doing the same basic activities. And then we flip from there into more of our system level processes. And there's 2 on the SPICE side, but together you're basically doing the same kinds of tests as you would on the ISO side in Part 4, Section 7, and it's called the system and item integration and testing. So you're still doing this integration and integration testing and some qualification, but it's done at a system level there. So auditors are definitely going to be looking to see if your processes are set up to do these 4 activities. And then what I see when I work with customers is many customers reuse their same processes because they're so similar here, and they can satisfy both standards. So they can just set up and run one process, but they can support both standards. Okay, so that's the area of overlap that I wanted to pull out for today and of importance. Now we're going to move on and start talking about the 5 key testing capabilities. So the first one is we're going to talk about native tool support for multiple builds. So what I mean like that is projects with multiple deliveries from the same code base. So maybe you work on a project where you only have a single build and a single delivery. Great, your life is easy. You can skip over this page. The vast majority of my customers, though, are working on like more platform software, or sometimes it's known as configurations or variants, sometimes parameters and calibrations as the terminology that's used. But basically the same code base is used to build and deliver multiple applications. They're very similar, but they are different in some ways. So what you want to be able to show an auditor how your tool chain follows and shares and propagates that multiple configuration setup or information. So maybe you have an A configuration and a B configuration. Well, how do you handle that? How is that entered in your requirement management system? How do you account for that in your version control system? How is it implemented in your build system? And then, of course, finally, how do your testing tools use that? So what I've shown on the slide here is on the right-hand side, or the top side, is just a little snippet of a dialog that's in our Canoe and VTest Studio tools, where you can see we support the ability to bring in multiple variants, and then you can pick between them as for different systems under test. So you can set up these variants, and they can be brought into the tools, and then you pick which one you want to test. On the bottom, I'm showing a view of the environment from inside of VectorCast. And inside of VectorCast, we support multiple configurations or variants by a feature we call specialized test cases. Our next key testing capability involves traceability. So this means that bidirectional links between your requirements and your test cases are maintained throughout all of your processes as well as your tool chains. Okay, this is a foundational capability that auditors want to see throughout all of your processes and to help ensure consistency. So especially when you're doing those multiple deliveries, They want to make sure that you're tracking and you're doing all the things you need to do for both like that A delivery as well as that B delivery. Ideally, you'd like to have tools that support many-to-many linkages like VectorCast can. So for example, that means you may have a single requirement, but it can be satisfied or linked to multiple test cases, or vice versa. You can have multiple requirements that are actually tested with a single test case. And typically, most projects have their requirements and their test cases in different tool chains. So there's usually some kind of communication that has to go on between the tools. So you want to make sure that your tools can interoperate between each other. So for this slide, I've showing our first view of the traceability matrix, which you can see inside of Canoe and VTest Studio. And with the traceability matrix, you can see the linkage between your requirements and test cases. And on the bottom, I'm showing the VectorCast user interface. And in the center on the bottom there is a list of requirements that have been brought into VectorCast. And right next to that is the test cases that are linked to requirements. So it just kind of gives you a quick view of how some of this capability is implemented in our solutions. Our third key testing capability has to do with coverage, measurement, and reporting. So coverage applies to your requirements, your test cases, as well as your source code. And in most cases, your requirements are measured and reported using some kind of a requirement management tool. So that activity and that development is focused in that tool. Whereas test cases and code coverage are typically measured and reported by the testing tools. So at a minimum, auditors usually like to see metrics for all three. And what they like to see are things like total counts, how many are there, how many have been completed or satisfied or passed, which ones are not complete, and then some details about why have they not been completed. So again, I'm showing a little bit different view of the traceability matrix inside of Canoe and VTest Studio. And from this view, you can see your requirements and how they link to test cases and test case results. And inside of VectorCast also shows requirements and your test case results, but in addition, it will show code coverage. And what I included here in the slide is just a little snippet of a metric report that is reporting out some statement coverage for some sample code that we use during demos. Okay, our next key testing capability has to do with impact assessment. Basically, what's the impact that a change to the product or the project is bringing into the source code? So it could be a new feature development or it could be a bug fix. And here auditors want to see that you have the ability to traverse the traceability chain. So basically you can answer the question, what are the ripple effects of a particular change? Do I have to rework some requirements? Which tests do I need to rerun? Questions like that. So you need to be able to bring that through. Does this change affect maybe my A product and my B product? Those are all kind of very interesting questions that the auditors want to make sure that you're able to correctly analyze and assess. It also can enable the ability to evaluate the risks associated with change. So is this a small change? Maybe it's a low risk. Is this a big change? Well, maybe that's a high risk. What do we want to do? That's all part of, you want your testing tools to help you with this impact assessment. And what typically happens is very early in the project is in a state of constant change. The feature, we have the initial release, the feature scope keeps expanding until all the features have been implemented. We're already doing testing, so you're fixing bugs along the way. Whereas later in the project, that pace of change activity really slows down dramatically. And later in the project, it may even be after you've gone into production. So that impact assessment, not only on the quality and how your process is running, but um, the financials come involved and the risk as well, because you don't want to release a new piece of software that introduces a new bug or forgot to check an issue or something like that. So for here, VectorCast has a specific feature to help you with this assessment. We call it our change impact report. So once you've established a baseline of testing and coverage, you can run this report, and VectorCast will look at the changes in your source code, and based on from your baseline to the changes, it can produce this report, which will tell you where it's seen changes, and it'll tell you what test cases are affected, so you know which test cases need to be rerun. Our last key testing capability is our automatic regression testing. Right? Automatic testing is always better than manual testing, right? This should be obvious to everybody. Auditors, though, want to see how the test cases and like what test cases get rerun after changes. So once you introduce a change and you've implemented it, well, some of your tests you need to run. Are you going to run all of your tests? Are you going to run all the tests in all 4 of your processes? Okay. So today, what I see when I work with my customers, they already use, or at least they have active plans to deploy a continuous integration server, which gives them this capability of automatically doing regression testing. So most of my customers today are selecting Jenkins as their solution, although we also see Bamboo and GitHub, a little more GitHub recently within the last year, as well as some other solutions we've helped our customers use. So for this side, instead of a screenshot of the tool for the Canoe and VTest Studio tools, I'm just showing more of kind of a design principle where we have a Linux server, and you can see we have the Jenkins server running on that same server. It's got 3 build nodes that are having Canoe run various tests. And Jenkins has got a lot of support for a lot of different use cases, and it can scale to very large build node farms and things. So what we're showing here is it also is set up to have a build node on a whole separate Windows server, and it's running a 4th Canoe instance that can run test over there. On the bottom, what I'm showing is the Jenkins plugin website. Because so many of our customers have been selecting Jenkins, we have a VectorCast Jenkins plugin, and it's on the Jenkins website. So from your Jenkins server, you just go to the plugins area and you search Vector, and you can just install it. And then this plugin, what it does is after you answer just a few questions, it'll set up a Jenkins job, and then you just need to run your job, and it will build and execute all your test cases in your VectorCast project. I've literally set up customers in like 20 minutes. So it's really easy to get set up and get rolling. Now, before I leave this slide, there's one other feature I do want to mention is VectorCast has our change-based testing feature. And what it does is it builds off of that impact report I was talking about on the previous slide, where once VectorCast determines what test cases need to be rerun, then it will only run those test cases. So that can save a lot of time, and in many cases it can enable an agile workflow for projects where they now can run all their tests that need to be run, within their 2-week sprint cycles or maybe even overnight. So it's a real handy feature that a lot of our customers really like a lot. Okay, so those were the 5 key testing capabilities I wanted to bring out to you today. I threw this slide together just as a helpful resource for you. I've got a couple links up to the top. We did a software testing factory webinar series. It's a great series. Kind of you'll see more of the tools in action and how to set them up and how they implement all 4 of those workflows I just got done talking about, or those 4 processes. And then just last month, there was a great article in our Coder's Kitchen It talks about testing levels from unit test to system test. It actually breaks it down into more than 4 different potential processes and how some of the different vector solutions would work depending on what you want to do. And then at the bottom, I have some links to both the Canoe portal and the VectorCast portal on our website, where you can find product descriptions, application notes, and case studies. And this brings me to the end of the presentation, ISO 26262 ASPICE Audits, Key Testing Capabilities. This presentation introduced both the ISO 26262 and ASPICE standards and highlighted how the two standards overlap. We reviewed the following 5 key software testing areas: native tool support for multiple build configurations, traceability between requirements and test cases along with the test results, easy coverage measurement and reporting of requirements, test cases, and source code, the ability to assess the impact of change requests and bug fixes, and finally, the automatic regression testing that's typically performed on a continuous integration server. Hopefully you found at least one of these key areas worth considering as you plan for your audits. Thank you for joining the presentation today. I look forward to your questions and to meet you in the Q&A session. See you there.